I hope you enjoyed the first half of this conversation. This portion is the live technical interview with our guest. Feel free to follow along and create a solution of your own.
So I want you to write a function that accepts a list of integers and returns to me the numbers in that list that have repetitions, that are duplicates. So basically, if you were given a list of numbers, like the numbers 1, 2, 3, 4, 5, 1, 2, 5, 6, just a list of numbers. Basically, your input is that list, and your output is everything in that list, every number, every element, every member that appears more than once.
Great. So write a function that accepts a list of integers. Do we want that? Can I assume that list is an array?
Yes. Generally speaking, when I've when this question has been asked either by me or next to me, would write like the method signature, the return type in a very Java format. So it'd be a public list int, find duplicates. The method signature would be a list of ints.
Okay. Great. As a JavaScript developer, that doesn't mean a ton to me, but
no, yeah.
Okay, and then returns the list. So return the duplicate. Would you like the duplicate in an array as well?
Yes.
Okay, great. And both numbers.
I just want to know all the numbers that have appeared more than once.
Okay, great. And can I assume there will always be a number that appears more than once?
You should make no assumptions about any kind of. There's a follow-up question to this about how do you test your function.
Okay.
That we'll put to the end of it, but you just know that you're getting a list of things and you need to find the duplicates. That's all you know.
So may not be any duplicates. And if there's more than one duplicate, more than one set of duplicates, you'd like both of those.
No, I just want to know. So in this case, if you had the number 5 one more time in there, I just want to know that 5 appeared more than once.
Okay.
I don't care if 5 only appeared once.
If 6 was in there twice, would you want 5 and 6?
Yes, correct.
Okay, great. Be more than pair of duplicates. Okay, great. So in this input, this example, 5 would be the output.
Mm-hmm.
Okay, great.
And do you want a few more examples, or do you think you?
Sure. Let's do another input. Yeah. Do you have another example?
It's like 10, 20, 30, -5, then 10 again.
Okay. And the output there would be 10.
Yeah, maybe add another -5 in there just for fun, so you have 2 things to return.
Okay, great. Okay, great. And it's a function. All right. So I think I understand what you are asking. So the first thing I would do is create the function itself. I think lots of ways to check which numbers would already exist. I could add the numbers to a hash, and then basically if the number is in that hash, then if that number is already, if that number is not in the hash, then add it to the hash. If the number is already in the hash, then either add that number to another array or return that number. I guess if we're going to do if there's duplicates, we could add that to a different hash and then return that one. So take array, you could do an index of the array, and if number array index is in hash, if not in hash, add it to the hash, if is in hash, add it to results array to be returned. I think that should work. So in this test case, it would see 1, it would add a 1 to the hash. It would see 2, it would add 2 to the hash. It would see 3, it would add 3 to the hash. Same with 4, it would add 5 to the hash, and then it would see 5 the second time. It would add it to the results hash, and then it would add 6 to the last hash, and then return 5 as the result. Okay. Likewise, this one would work the same because we're not going to return the actual result hash until it's been fully looped through. Great. I think I can start to code. So function, we can call this
we always would find it find dupes or find duplicates.
fine. Great.
I'd always be scared about putting the word return in anything that wasn't a return statement.
Sure. Array log, find duplicates, and we can throw this one in there as the first test. Okay, great. So we've made a function. We'll need to loop through this array. We also need to make the hash. Let's think of a better name for this hash. For the numbers to go into initially.
I just call it dupes.
Yeah. Dupes equals, oops. Okay. And let results equal. Oh, I want this one to be the non-dupes and the results to exist. Okay. And then it will return result. So we've made the hash, we've made our results hash to be returned, and then now we just need to loop through the array and then make what will be if statements. So different types of, plenty of different types of loops you could use. I think a for each. could work
Yeah,
well.
at this point, the type of loop that you choose is really inconsequential, right? Whenever we would ask this question, it wasn't about, you're gonna have to loop through things no matter what. It's sort of a question of when you're in the loop and when you're out of it, what are you doing then? But loop choices are depends on the language you're using. If you're using something like Ruby, there's about 8 million different ways to loop through an array. If you're using something much more strict like C or to a certain extent Java, your choices are much more limited. So
yeah. Okay, so we can do a for each loop. Let's see. So, so if my array's mad at me, or my loop's mad at me, my syntax here. I
honestly don't remember how Node does this syntax here. Node. It's been a long time since I've looked at Node syntax.
Yeah.
Basically JavaScript, right?
Maybe that'll.
I think you have to pass a function to the for each. So you basically pass a callable, it looks like. So if you say for each parentheses and then put a function within there,
Right.
The function is where you put your individual element of the array.
Yes.
And then you gotta, it's the pros and cons of having a callable like that, is that the recent versions of Java have tried to make that more readable. Although something like Node, that's part and parcel of living with the language.
I keep trying to get used to arrow functions, rocket hash arrow functions, fat arrows as well. But I feel like sometimes I shoot myself in the foot when I'm like, oh, let me be fancy and throw this in here. Okay, so if, let's see, I don't remember how to call it in a hash. So we want to see if it is in the hash, which we could just do be none. I don't remember if that's the correct way to call it.
I don't remember, because you're effectively making an object with curly brackets. Did you want help with this, or do you want me just to shut up and let you get through it?
I would say let me struggle as much as possible, like as much as
I'm
you would in a
solve the
normal
problem
interview.
too.
Yeah, I'd say as real as a normal interview, and then if it's too painful, we could work through it.
Nah, I see code and I want to start solving it myself. I don't remember the language either, so I have to remind myself how the language works.
Well, if you want to have the syntax on file, because I think that'll be the biggest issue for me. I just need to know how to check if the hash has this.
Yeah. I thought there was an in directive you could use, but node check. You basically want to check if a value is in the object.
Yes.
Because you're going to be doing a key value pair, right?
Yes.
Is that the data structure of choice for this guy?
I could call it without even having a key.
So the curly brackets, I thought in Node define an object, which is basically a fancy way of saying key value pair. So your key has to be a thing, and then your value has to be a thing. So you can't just like shove a number in there. You have to shove a key and a value.
Yeah.
Maybe you're thinking about using an array there instead, but the curly brackets create an object, which is just a series of keys and values.
Yeah.
So there's a has property or has own property function I think you can call, but yeah, because in using the positional accessor there won't work, because you have to if you set those to an array with the square brackets instead of the curlies, then it would work. But since it's an object, you can't access things by position. You have to access by name.
Oh, interesting. Can I leave it as an empty array?
You have to do a square bracket there.
Square brackets, right?
Yeah.
I'm trying to remember why I know I've done something similar in the past where I definitely tried it as an array because I feel more comfortable with that, and then it didn't. I couldn't get it to work. So I'm not entirely sure. We'll see how it goes. The else would be basically adding it to the results hash, but we could also make that an array.
Might be I think it's dot add.
Yeah.
Dot push.
Push is how you put it onto the end of it.
I believe so.
Yeah. So if non-dupes number, we want it to go into.
So you're probably going to face a problem there, I'd say. Remember, arrays, you access things based on positions, but if you try to access something in a position that doesn't exist, you may encounter an error of some sort. I don't know about how Node thinks about it. So let's take your second example with like 106, right? What your code on 123 is effectively saying is, look in this array at position 11, because as we know, arrays start at 0. So you're saying find me the element at position 11, and do an if statement on that.
Yeah.
So depending on I don't know if Node has something special in this, although I don't think it works this way. If you just tried to check for something, or maybe even push something, you're going to push the element. Like in that case, you don't have 10 in that array. So just without thinking about the data structure, the first thing you're going to do is say push, and you're going to push the value 10 into the 0th position of that array. So it's not going to work the next time you go through that with the number 10, because you're thinking, I want to, this is an array, I'm going to put it at the 10th position, but arrays are, you just put something in, it's at the latest end part of that array. It's first in, first out,
right,
kind of thing. So array is probably not the kind of data structure you want to use here, unless you use it a little bit differently, because you want to check about position within the array. You could put the number 20 as the 0th element of the array. That doesn't mean it's in the 20th position. It just means it's the number 20 in an array.
Yeah. And I think could I run not dupes.include number?
Yeah, absolutely. Because that'll then scan. I'm sure that the way it works, it'll scan through every element of the array to see if the argument you pass in is part of that array. I don't know if includes is the right call for that, but now this we can get to the part where we talk about your solution right away with that if you want.
I want to make sure that else. I don't know if I need to do an else if or traditional. I think if it's not, I don't think I need an else if there, right? Because if it's not already in the array, if it does not include the number, it's getting pushed into it. Otherwise, everything else
Yeah, because the first time you see it, uh, well,
Oh, this
if it includes
is,
it, you don't want to. Yeah.
yeah, okay.
So,
So if it does not
yeah,
include
those.
it, push it to that. So then that'll enter into dupes else, add it to results. Okay, let's see if the syntax here. Okay, great. So that works for 5. I can see if that works. It should work for this one as well. 5 and -5. Okay, great. So that seems to work for that use case, at least.
Mhm.
Um, I guess, what do you see about this that could be different? That would, I mean, we
Yeah.
make sure we're answering all the returns the number in the lists that have duplicates, right? So I think we're
Mhm.
solving the original problem.
Yep. So it definitely does. Um, so this is the fun part where we start to think about the potential solutions for the scope of this problem, right? Um, what is going to be the computational complexity of this problem? This is where you can get into deep rabbit holes when you're talking about computer science, data structures, algorithms courses, where you talk
Yeah.
about theta notation and stuff like that.
So we're running a for each loop, which is going to run through every single potential element in this array.
Mm-hmm.
So that'd be
Mm-hmm.
O of n time, at least.
Yep.
Um,
For what it's worth, I'm not great at answering this question either. So this might be like an n times 2 or 2n type of thing, because
yeah.
you're going through the array, and then the important thing is on line 123 there. When you scan through an existing array, the array, you could have a worst case scenario here where everything is in the input is a duplicate. So you have like a series of 100 numbers, and there's 50 distinct numbers in there because every number is repeated exactly twice. So once you get to the end of it, not only are you looping through an array of 100 things, but you're also then looping through maybe at most 50. But um, there's a way to design an input to this that could do like an n, at least a two n kind of complexity. I don't think you could design something with a n squared, but it's at least 2n.
Yeah. Um, would using a hash do that, or
Well,
allow you to search through that easier? Or
so
you're saying without changing the data structure?
yeah, this the way that you solved it is one that is probably the second most seen solution that I've seen when people me ask this question. Generally speaking, the most popular way that I've seen this question answer, and the one that always comes to mind first for me, is kind of to do exactly what like your brain does when you look at the input, which is to look at it and say, count the number of times that you see something,
Mm-hmm.
right? So if in that first example on line 106, if you put the number 10 in there again, what I think we as human beings sort of do, or at least most people do, is say they're going to scan through it and just count the number of times you see every element. Which, remember, the question is not about how many times you see it, it's just, have you seen it more than once?
Right.
So the easy solution would just be to, and they're not easy, but the most common solution, the one that I always gravitated towards, was like, well, I'm just going to scan through it, create a series of key value pairs, and do an accumulation function as I go through everything, right? So first time I see 10, I'm going to see that I saw 10 for the first time, set a value of 1 as my value in the key of is 10. The next time I see 10, I'm going to add 1 to that that one, so I've seen it twice. And then the next time I see it, I'm going to add another one to that two, and that we'll see that I've seen it 3 times. So basically just writing an accumulation function to say, count the number of instances of each of these things that I've seen. Now, the extra thing that you need to do once you get out of the other side of that accumulation function is then look at that object, that series of key value pairs, and say, find me everything in this key value pair, which has a number greater than or equal to 2. And that itself is another loop, another for each, right? So basically, if you fed in an array that had 100 elements and none of them are duplicates, then you'd be running through an array of 100 things and then running through yet another array of 100 things. So your complexity would be 2n, right? And then you could also ask questions at this point about the memory, like the memory usage, the memory constraints, right? This is where, like, let's say that I was memory constrained and you wanted to find, your CPUs were infinitely powerful, but you had a very small amount of memory. Like, how would you rewrite the solution to this to meet that constraint? And then you can do the inverse to say you have infinite memory, but you want it to be as fast as possible.
Yeah.
So the solutions become very different based on the circumstances. And it gets kind of interesting from there.
Yeah, interesting. Yeah, and I think the solution you just walked through is also, I've heard this question asked where they also want basically the result sorted based on what is how many times something comes through, and that makes it easier to do that as well. I think with my solution, that'd be really difficult to do, right? Because right now there's really nothing that is tracking that versus if you have the amount of time something shows up. Yeah.
Well, some of the more, I guess, ingenious is maybe one way to say it, but some of the more clever ways of solving this problem would be to do like an incremental scan through an array that's put in. So if you did the work first to sort the array, that was given into you, because you don't have anything in the problem statement that says the array always sorted.
Right.
And in fact, you saw there were negative numbers in that second example, so that maybe is a little bit hint. So if you were able to sort the array first, and then you could see that you could basically take it token by token and say, like, once I see something once, if I see the same thing immediately following it, you can skip that for a certain number of elements in the array. And then you can avoid making a secondary data structure that, like, is an accumulation. It would take a bit more computational complexity if you wanted to execute quickly, only because scanning through arrays can get sort of expensive depending on the language and things. But it would use the least amount of memory to do that kind of thing. And you just have to kind of keep your variables straight, really, which is more sometimes you fall into problems with these kinds of things.
Yeah, interesting. There's a great, I think I saw a recent example. It was a video put out by Google where someone walking through one of their interview questions. And I think it was that same type of question. And basically it started with, the array is going to be sorted. And, they had one solution, but then the follow-up was, now you can't, like, you actually have to sort the array as well. And I think it was a really useful, the question itself was a little difficult to kind of follow, but the solution, just watching them walk through it, was interesting. And I'll add it to the notes on this, so people can see it. Great.
Yeah. Usually at somewhere near the end, you'd ask the standard, like, well, how would you test this, right? Like, and the tests kind of come in a couple easy flavors. It's, pass something in with duplicates, pass something in with no duplicates, pass in an empty array. Usually try to find well, what if I pass in the value of null if the language allowed it?
Sure.
So depending on how pedantic you want to get about null checking, you could say, like, okay, well, I could then, if null, if the input is null, check in there to do something there. And like, this is not a difficult problem necessarily, and as you've seen, there's a couple different ways to solve it for sure, but they all come with trade-offs. And I think the nice thing about this problem is that it makes you, it makes the person you're talking to say and talk about those trade-offs.
Yeah.
And to talk about like, well, if you're trying to optimize for speed, you maybe do this way. If you're trying to optimize for memory constraints, you do it this way. If you don't care about either one of those two, you can just brute force it. You can really take the solution. And sometimes the first answer that somebody gives you before you start to change the conditions sort of tells you a little bit about how they're going to solve problems. If they're going to solve every problem as a memory constraint problem, or if one is something that they want to write the fastest possible code, it gives you a bit of a hint as to how people think about solving the stuff, which is cool to see too.
Yeah, interesting. That makes a lot of sense. I haven't even thought about that from like an interviewer perspective, just the way someone approaches a problem. I know I used to talk a lot when, prepping people was like, make sure you're talking throughout, right? Because I think it's difficult if you're an interviewer and you just have someone silently looking at a board or, silently coding even or writing something out. It can be difficult to understand exactly what they're thinking versus like, at least they're saying something out loud that you can follow along with.
Yeah. Well, I mean, it also touches a little bit on an earlier point I made, which is in situations like this, especially if you're putting someone up in front of a whiteboard and writing code on a board for me is always impossible because it's like give me a damn keyboard, because like there's going to be an IDE that's going to have some nice tabbing in there. I'm really going to blast through it. You don't want to put someone up the board and then fold your arms and stare at them and say, wait until they spit something out. Like you can nudge them forward, you can help them out. You don't have to make it something that doesn't give somebody help, like just gives them the noose to hang themselves with. This is just about a little bit about being a good human being to someone that you're talking to who would probably be nervous. So,
absolutely. Great. Well, I appreciate it, Alex. Anything else to add? Anything to plug? Anything you want to share?
Coffee mostly, obviously. That's the one day I'll quit my dead end day job to sell a physical product, which is the dream that every software engineer I'm sure has. BuiltIn is a great place. I know we have a lot of roles open, obviously, as a lot of companies do. But as far as interviewing goes as well, this is stuff that every company is different. Every interview process is different. Just know that even if you're interviewing somewhere and it's as much about them interviewing you as you interviewing them. So if you don't like the way that their process is functioning or the way it works, then it's easy just to say that's not the right place for you, and that's okay. That's totally okay. You will spend, and I've spent, and I'm sure you can reflect, Taylor. You don't land every job that you go for an interview on. In fact, probably in my life, it's been like 1 out of 10. Which is a pretty big ratio. It's just easy to forget that when you're in the middle of it. So,
and it's really easy to get one, just have a lot of time wrapped up into something, and two,
of course,
have a lot of emotions and kind of excitement wrapped up into a job that you feel like is the perfect thing that might just get destroyed by one email or one phone call that says, sorry, we're not moving forward.
There'll always be others in the scene. It's dating. It's the exact same thing.
A lot of jobs I was going to say in Chicago, a lot of jobs in the, the job market, right?
Yeah.
Great. And I, once again, am a good supporter, proud supporter of Maple Leaf Coffee Roasters. And there's a fantastic subscription service if you are trapped inside and don't like buying coffee from your grocery store anymore, where Alex will have someone deliver it to your house and you get higher quality coffee than the stuff that I was buying before. So
Absolutely.
Great. Well, thanks so much.
My pleasure. Good to talk to you.
Yeah, absolutely.